Hello all. Previously we have seen how to insert a node at the beginning of circular single linked list. Now in this video we will see how to add a node at the end of circular SLL. To do this I am using a user defined function called insert at end. It will accept a node value as a parameter. First we need to create a node by using a malloc function. Once the memory is allocated, then assign the value, whatever you want to add, assign the value. And instead of going through each and every line of the code, I will take an example. I will show you the algorithm. I will take an example and I will explain with that example. That would be better. So let's get started. So this is the algorithm. First create a node as I said earlier and assign a value. Check if the list is empty. If the list is empty, that means the whatever you are going to add a node, that will be the first and last node. Is it? So check that. If head double equal to null, it means there are no nodes. Then first whatever the temp next should point to itself. So assume that there will be no nodes initially. So if you call insert at end, that will be the first node and that will be the last node, right? So for this purpose, whatever you are going to add that node, you just add a circular reference so that it will point to itself. How do we do that? As I said in our previous examples, temp next is equal to temp, so temp will point to itself. So that is a circular linked list property. And once again head and tail should point to temp so that the first node will be created. What if the list has some nodes and you are going to add a node at the end of circular SLL? For this purpose, you need to execute the else part. First, create the node, assign the value. Once it is done, check these conditions. Once there are so many nodes in the linked list or some nodes in the linked list, then else part will get executed. First, link tail to the new node. How do we do that? Tail next is equal to temp. So whatever the value of temp, whatever the address of temp, that will assign in tail next part, so that tail and new node will be interconnected. And then point new node to head, so that the circular structure will be formed. Whatever the temp next value, in the temp next assign the head address, so that the temp next will be pointing to the first node. Obviously the temp next is going to be the last node, right? For this purpose, move the tail pointer to the temp part so that the temp node will becomes the last node. So previously tail will be that some other location, right? Now tail is equal to temp. The temp is the newly created node. So whatever the newly created node address, that will be assigned in tail, so that tail will move to the last node. This is the logic we are following. Okay, so this is the code. So let me go through the example. Let us say the linked list is like this and we are having 3 nodes, and now you are going to add 40 to the existing linked list. Since the linked list is having some nodes, that if part will be skipped. So this head double equal to null won't be executed because there are some nodes with respect to our example. So this condition will be skipped. The else part will now executed. First make tail next is equal to temp, so that tail and temp will get linked. Here the previous address is something else. Now tail next will have the temp address, so that tail and temp will have the link between them. Now then we have to form the circular structure. How do we do that? In temp next value, assign the head value, so that temp and head will have the interconnection. That forms a circular linked list. Now move this tail to temp. How do we do that? Tail is equal to temp. Whatever the temp address, this temp address, let us say 400. This 400 will be assigned in tail. Now tail will move to the temp part. So this is the updated linked list diagram. So in this fashion we can add a node at the end of circular single linked list. Now let's see the execution in devcpp. I have a code in devcpp. This is the insert at n function, and initially I'm adding 10, 20, 30 to the circular SLL, and then I'm displaying the initial circular SLL, and once it is done I'm adding 40 to the linked list and I am displaying the circular single linked list. So now let's execute this code, execute and compile and run. So as you can see here, this is the original list 10, 20, 30, and after that I have added 40 at the end of circular single linked list, and this is the updated linked list. So in this fashion we can add a node at the end of a circular single linked list. Thank you so much for watching. I will see you in my next video.